congruent angles. Congruent, remember, is that word that's like equal, but it applies to shapes. So congruent angles are going to be angles that have the same measurement. I also am going to introduce you to the idea of angle bisectors, and we'll use congruent angles to solve problems. So a little notation. Angles that have the same measure are congruent angles. That means that if I used my protractor to measure these angles, I would get the same measurement. We still use that equal sign with a squiggle on top of it to mean congruent. And on the diagram, we mark them with the same number of arc marks to show that they're congruent. So angle TUV is congruent to angle XYZ. They both have one tick mark, but then over here, angle FGH and JKL have two tick marks showing that those two angles are congruent to each other. I'm also going to introduce the word bisect. Bisect, if I break it up into its parts, has bi, which means two, and sect, which means cut. Bisect is to cut in half or cut into two parts that are equal. So bisect is cut in half. A perpendicular bisector is for a line segment. It is a line that cuts the segment in half. And makes right angles with the line segment. The right angles come from the fact that it's perpendicular, but the bisector is what cuts the segment in half. An angle bisector is a ray that cuts an angle in half. So when you see that word bisector, make sure you think, oh, cut in half. Two parts, cut. So if I'm looking at this diagram, I would like to mark the diagram. I'm going to mark each of these parts. The first thing I notice is that JKL is congruent to NKM. If I highlight JKL, that would be this angle, and NKM is this angle. So in my diagram, I want those two angles to have the same number of arcs on them because they are congruent. And then my next statement is that angle J is congruent to angle M. Angle J is this angle because there's only one angle with a vertex at J. Angle M is this angle because there's only one angle with a vertex at M. And if I want to mark those two angles, I would mark with two tick marks, so I'm showing that these are different ones than the other ones that I just marked were congruent. So two arcs to show that they're congruent. And then just a reminder about notation, if we have this kind of congruence for line segments, JK is congruent to KM. That means that's their line segment, so I'm going to mark those with a tick mark on the line segment, showing that those are congruent. This is a picture, and I'm asking you to name the bisector. These are both angles, so if I see the word bisect, I'm looking for the ray that cuts the angle into two congruent parts. The ray is MN. Remember, for a ray, we need to start with the end point and then put an arrow on top. And the angle that it bisects would be angle OML. Or, if you saw it this way, you could call it angle LMO. Make sure that M, which is the vertex, is in the middle when you name it. So make sure, because M is in the middle, the vertex, you need M to be in the middle of your name. And then for number 3, I have URT and TURS are congruent, so that means that RT is my bisector, and it is bisecting angle URS, or another way to write that angle would be SRU. Okay, there are some examples in your packet that I'd like you to try, and I will post my answer key online, but you should try the examples first. Thank you.